Hey everyone, today we're going to continue with our circuits. For today what we're going to do is we're going to look at current, voltage, and resistance, which are the three things that we use to describe circuits. So what I mean by that is if you're trying to figure out what an object is or what it's doing, you can use values like the distance it traveled, the speed it's moving at, the acceleration, and so on. For circuits, we don't use things like speed or acceleration. We use current, voltage, and resistance. So for today, we're just going to try and figure out what these three things are, like what they mean, and how they're related to each other. And that'll be it for today. Alright, so let's start with electrical current. What current is it's the amount of charge moving through a circuit. So it's basically just the value that we have for the amount of electricity moving through the circuit. A high current means there's lots of electricity, and the electricity is moving very fast. A low current means that there's not so much electricity. The electricity is moving very slowly through the circuit. Now, when I say electricity, what I mean is electrons. So remember, electrons are the particles that are free to move around. Protons are not. So when I keep saying that electricity is moving, what I'm really referring to is the movement of these electron particles. So current, again, is just how fast the electrons are moving. If a lot of them are moving very quickly, or if only a few of them are moving relatively slowly. So that's current, again, just the amount of electricity, how fast it's moving. Voltage. Voltage is, there's a few different mathematical definitions we can use for voltage, but for us, we'll just settle with this. Voltage is like the electrical push through the circuit. So think about it like this. Let's say you have like a wire. Like this. Wires have atoms. Atoms have electrons. So there are electrons in this wire. But there's no current. And the reason for that is nothing is pushing the electrons through the wire. This is, right now, just a piece of metal. In order to move the electrons, in order to generate current, you need some type of push. We call that voltage in electricity. So I could connect this wire to some sort of battery or power source, plug it in somewhere, and then there's a voltage. There's like a push through our circuit that would create current. So voltage is like the electrical push. Now, more voltage, again, think about it like this. If you have lots of voltage, you have lots of push. Like there's a big, strong battery pushing really hard. More voltage would give you, more current. So again, the idea is that if you have like a really strong electrical push, you have lots of batteries or like a really strong one, you would have a lot of current moving through that. Because again, you're just pushing really, really hard. Now the other side of that coin is resistance. Resistance is the ability to slow current. So I just wrote slowing current down. Which kind of makes sense. Resistance is what it sounds like. If you resist something, that means you're like stopping it or trying to oppose it. You're trying to block it. And resistance is the ability of an object to do just that, to slow down or block electrical current. Some materials have a very high resistance, some have a low resistance, so some materials are a little bit better at moving electricity than others. So if you have more resistance, meaning you resist harder, then there would be less current. So resistance is something that you have to account for if you're designing an electrical circuit, because this is, again, the amount that a material or an object or a wire or whatever it might be slows electricity down. So to kind of recap these three things, current is the amount of electricity, and it's affected by a couple of different things. It's affected by voltage, and it's affected by resistance. Voltage is, if you have more voltage, you will have more current. If you have more resistance, you will have less current. So basically, this is your push, and this is your resistance. This is your slowing it down. So let's try a couple examples. I think you'll get the hang of this pretty quickly. We're going to do 23 through 25 together, and then I'll have you try 26 through 30 on your own. We'll see how it goes, and that'll be good for today. Alright, a toy car is powered by a 9-volt battery. If a 12-volt battery were plugged into the same toy car, would there be more current or less current flowing through the circuit? Alright, well, if we have a 12-volt battery, that's more volts, right? It's a bigger voltage. That's more push. And so there would be more current, Because this battery is pushing harder. It's a bigger battery, it's stronger, and it'll really push electricity through it. Which might be good or bad. Probably the toy car would either go really fast or it might break, because again, it's not designed for that much voltage. 24. A variable resistor is a device that can change its resistance so that the current through a circuit can be adjusted. If the resistance of a variable resistor increases, so we're going to take if the resistance increases, what happens to the current? Alright, if the resistance goes up, we're resisting harder. We're resisting harder. And so the current should decrease. Because again, you are resisting that more. You're slowing it down more. 25. While performing a lab on electrical circuits, a student notices that the current through the circuit suddenly increases. So the current increases. Which of the following could explain this? The voltage went down, the resistance went down, the resistance went up, or the power went out? Let's start with this. The power went out doesn't make sense, because then it would just totally stop working. The current wouldn't go up, there would just be none anymore. So D is wrong. Okay, so the current increases. Let's talk voltage first, because that's answer choice A. Alright, the voltage went down. That means we're pushing less. Would that result in more current, or more electricity? I don't think so, right? Because if you want more electricity, you should push harder. So I don't think A makes sense. B, the resistance went down, or C, the resistance went up. Alright, so these are kind of the two opposites here. If the current increases, there's suddenly more current. I think it's because we resisted less, right? Meaning, like, we're not opposing it, we're not stopping it as much, and so there would be more of it. So the answer to this one is C. Oops, no, sorry. That's wrong. The answer to this is B. The resistance went down. There's less resistance. We resist less, and so the current, there would be more of it, because again, it's not being resisted as much. Okay, so I want you to pause the video at this point and try 26 through 30, basically this page 9 here. See what you can do with it. And so pause the video now, give those a shot, and I'll go over them in a minute. Alright, 26. If the resistance of an electrical circuit is doubled, what happens to the current moving through the circuit? So the resistance is doubled. We're resisting harder. We're resisting more. What do you think would happen to the current? Well, if you resist twice as much, then the current should be half. There we go, because you're resisting more. If you wrote decreases or smaller or anything along those lines, I also would have taken those. So anything that reflects the idea that you understand that there would be less current as a result would be good. 27. Outlets in the United States provide a voltage of 120 volts, while most outlets in Europe provide a voltage of 230 volts. Why would it be dangerous/harmful to plug an American-made device into a European outlet? Okay, so if you've ever been abroad to Europe, you notice that the outlets are shaped differently, and the reason for that is so that you don't plug your device into their outlets. They've got roughly twice as much voltage, and so if you plug your, whatever it might be, your laptop, your phone, whatever it is, into their outlet, it would push twice as much electricity through your device, and that would be dangerous. Everything that you have isn't designed to operate like that. So you could start smoking or light on fire or something like that, which is why you need an adapter in order to plug into those outlets. So why would it be dangerous? Basically, there would be too much voltage, which is kind of like a really straightforward answer, just because I wrote in the problem that it's much larger. But having too much voltage would sort of result in too much current. So basically, both of these two things would happen. They're both good reasons why that would be dangerous. 28. In order to reduce the current moving through a circuit, would an electrical engineer want to increase the resistance or decrease it? Okay, we want to reduce the current. We want less current. And if we want less current, I think we want to resist more. So the answer to this is increase. If you increase resistance, you're slowing it down more, so there would be less current. 29. Conductors are materials that conduct electricity very well, like wires, metals, that type of thing. And insulators are materials that do not, like wood or rubber. Which type has a lower resistance, conductors or insulators? Well, if they don't resist, that means that the electricity could move through them, because it's not encountering resistance. And so the lower resistance would be conductors. Insulators have a very high resistance, so high that electricity really doesn't move through them at all. Number 30. Describe two changes that could be made to a circuit that would increase the amount of current moving through it. So this is kind of a tricky one because the question is kind of vague. But a couple things that we can do to increase current. Well, current is affected by voltage. But what would we do to that voltage in order to increase the current? Well, I think we would want more voltage, more push, to get more electricity through it. So we could increase the voltage. It's connecting a bigger battery. It's pushing harder, so you would have more current moving through it. So that's one of the changes that we could make. The other one that would be a little harder to do because it sort of depends on the materials, although I guess you could add more devices to it. A change that you could make to the circuit as well, current is also affected by the resistance. So to increase the current, I think you would want to decrease the resistance. You would want to resist less. So these are two different things that you could do to your circuit that would increase the amount of current moving through it. Okay, and that's it. So what I wanted to get out of today is to kind of just understand what these three things are and how they're related. So current, the amount of electricity, voltages are push, and then resistance is resisting that current. More voltage gives you more current, and more resistance gives you less current. And if you can work with those ideas, that's what I wanted you to get out of today.